In this video, we're going to be solving exponential equations with like bases. What you should learn from this video is you should be able to solve exponential equations with like bases. Then you should be able to solve exponential equations when the bases can be made the same. They don't start out the same, but then you can make them the same. So what is an exponential equation? It is an equation that contains exponential expressions. And I want you to look right here and see the difference between an exponential expression and a power expression. An exponential expression has a number for the base. The power expression has a variable for the base. An exponential expression has a variable in the exponent position, and a power expression has a number in the exponent position. To solve these types of equations, we're going to be using a property called the property of equality for exponential functions. And that property says for b, the base, greater than 0, and for b, the base, not equal to 1, if b raised to the x power is equal to b raised to the y power, then the exponents x and y have to be the same. Notice that this says I have two powers, b to the x and b to the y. They have the same base and they are equal to each other. So this base and this base are the same. They are equal to each other. If that is the case, then these exponents x and y must be equal to each other. So let's look at this equation now. It's already worked out for you here on the screen because I'm not running the slideshow. But I'm going to come over here and work it with you so that you can see what's going on this slide. So to solve exponential equations, the first thing I have here is my equation. 2 to the 3x minus 3 is equal to 2 to the 9th. All right? The first question is, are these bases the same? Yes, these bases are the same. And since their bases are the same, we can then take this exponent and set it equal to this exponent. So 3x minus 3 equals 9. At that point, we're just going to solve for x. So we're going to add 3 to both sides. So 3x equals 12. And then we're going to divide both sides by 3. So x equals 4. You should always check your answers, and that's what we did right here on this side, the right side of the screen. I took this 4, went back to the original equation, and put it in for x. So 3 times 4 is 12, 12 minus 3 is 9, and 2 to the 9th is equal to 2 to the 9th. What I want you to do now is try these 3 problems, and I want you to pause the video, try these 3 problems on a sheet of paper, then come back to the video and check your work. All right, here are the solutions to the 3 problems. In the first problem, notice that the bases are the same. Set the exponents equal because the bases are the same. So 2x equals x minus 2. Then we're just going to subtract the x from both sides. 2x minus x is x, so x equals negative 2. In this next one, the bases are the same, 7, so we're going to set 2x minus 1, the exponent, equal to 3x plus 7, the other exponent. Then I'm going to subtract 3x from both sides. 2x minus 3x is negative x. And then add 1 to both sides. 7 plus 1 is 8. The opposite of x is equal to 8, so we're going to divide both sides by negative 1 or multiply by negative 1 to get x equals negative 8. In the last one, your bases are both 5, so we can set the exponents equal to each other. 6x minus 4 equals 4x plus 8. Subtract this 4x to both sides. 6x minus 4x is 2x. Add 4 to both sides. 8 plus 4 is 12. Divide both sides by 2 and get x equals 6. Be sure to check your answers to make sure that they are correct. Now, we're going to solve equations, exponential equations by equating the exponents when the bases are not the same, but they can be made the same. So here I have an equation 4 to the x equals 1/2 to the x minus 3. The base here is 1/2. The base here is 4. So these two bases are not the same. So I'm going to come over here and I'm going to write this one down for you as well so that we can work through it together. So 4 to the x is equal to 1/2 raised to the x minus 3 power. So the first thing I have to ask myself is, since these bases are not the same, can I write them with a common base? And in this case, the common base that I'm going to use is 2. So the question then becomes, how do I write 4 with a base of 2? Well, 2 to what power is equal to 4? Well, that's 2 to the second. So 4 is the same as 2 to the second. So 4 raised to the x power now looks like 2 to the second raised to the x power. Then the next question becomes, how can I make 1/2 a base of 2? Well, to do that, we need negative exponents. So 2 to the negative 1 is the same as 1/2, because this negative 1 in the exponent position means the reciprocal of 2 to the first power. So that's 1/2 raised to the x minus 3 power. Now the next thing that we're going to do, when we raise a power to a power, we have to multiply the exponents. So 2 to the second raised to the x is 2 to the 2 times x, so 2 to the 2x. 2 to the negative first raised to the x minus 3 power, that's raising a power to a power, is equal to 2. Now here I'm going to have to distribute, so negative 1 times x is negative x, negative 1 times negative 3 is positive 3. So that's 2 to the negative x plus 3. Now my bases are the same, so I can set my exponents equal to each other and solve for x. I'm going to add x to both sides, so 2x plus x is 3x. So 3x equals 3. Divide both sides by 3, so x is equal to 1. Again, we're going to check our answers, and that's what we did right here on the right-hand side of the screen. We said 4 to the first power is equal to 1/2 to the 1 minus 3. I took these x's out and put this answer of 1 in place of the x. So 4 to the first is just 4. 1 minus 3 is negative 2. 1/2 to the negative second power, that means the reciprocal of 1/2, which is 2, squared. So the reciprocal of 1/2 squared is 2 squared, or 4. So this checks. Now it's your turn. I want you to stop this video, try these 3 problems, then come back and look at the solutions. Here's the first solution. 2 to the x minus 6 equals 1/8 to the fourth. How do I write 1/8 as a base of 2? Well, 8 is the same as 2 to the third, and since this is the reciprocal of 8, this is the reciprocal of 2 to the third. I'm going to multiply my bases, so negative 3 times 4 gives me negative 12. Since my bases are now the same, I can say x minus 6 is equal to negative 12. And then all I have to do is add 6 to both sides, and I get x equals negative 6. Here's the second one. 3 and 1/27. Well, these are going to have a common base of 3. 27 is 3 to the third power, and since this is the reciprocal of 27, that's 3 to the negative third power. I'm going to have to distribute when I set my exponents the same. So negative x equals negative 3 times 2x, which is negative 6x, and negative 3 times 5, which is negative 15. Then I add negative 6 to both sides to get 5x, and then I get 5x equals negative 15. Divide both sides by 5, and I get x equals negative 3. And here's the last one. 4 to the 3x equals 1/16 to the first. Well, 4 squared is 16, and since this is the reciprocal of 16, we're going to change 1/16 to 4 to the negative 2. So that's 4 to the 3x equals 4 to the negative 2 times 1. Since my bases are now the same, I can set my exponents equal. 3x equals negative 2. And here, this one's pretty simple to solve. All I have to do is divide both sides by 3, and I get x equals negative 2/3. Always be sure to check your answers on these kinds of equations to make sure you haven't made a careless mistake. All right, here's one more to try. I've given you the answer, and I want you to try this one and see if you can get it right. Pause the video, and then come back, and we'll work through it together. All right, here is the answer. 9 to the x equals 3 to the x plus 2. The common base here is going to be 3. 9 is 3 squared raised to the x equals 3 to the x plus 2. Raise a power to a power, you multiply the bases. So 3 to the 2x equals 3 to the x plus 2. Bases are now the same, so we're going to set our exponents equal. Subtract x. 2x minus 1x is x, so x is equal to 2. Okay, I want you to pause the video and try this one. All right, now let's look at this one together. 3 to the x equals 1/9 to the x minus 3. Common base here is going to be 3. 9 is 3 squared. Since this is a fraction, or the reciprocal of 9, I'm going to change this to 3 to the negative 2 raised to the x minus 3. And that's going to be equal to my 3x. Now my bases are the same, so I can set my exponents equal. Raising a power to a power, I multiply these exponents. So I get x equals negative 2x plus 6, because I have to distribute. When I add 2x to both sides, I get 3x equals 6, or x equals 2. Okay? Last one. I want you to pause the video. This is the answer you should get, and let's see what you can do. All right, we're back. So let's do 9 to the x plus 4 equals 27 to the 4x. Common base here is 3. So 3 squared is 9. 3 cubed is 27. When I raise a power to a power, I'm going to multiply the exponents. So 2x plus 8, remember to distribute, equals 3 times 4x is 12x. All right? This time I'm going to subtract 2x from both sides because there's an x here, and the 8's on this side, so I'll just leave it there. Subtract my 2x and I get 10x equals 8. Divide both sides by 10 and I get 8 over 10, which reduces to 4 over 5. Okay, always be sure to check your answers and make sure that you're getting the right answer. Okay, I hope these helped. Have a good afternoon.